Hi there, we are now starting our next chapter on exponential functions. Today we are going to be focusing on solving exponential equations, specifically where the bases are the same. Here's the situation we're looking at. These are your powers, and so this is an exponential equation. B represents the base raised up to some power. So if you have a base raised up to a power, b to the x, equals another base raised up to the power, then you can take the exponents and set them equal to each other. Now, notice b means it's the same base. That b is not a different b than that. So here's the kind of situation with some numbers. If 5 is our base, 5 to the x equals 5 to the third power, then that means that x must be equal to 3. Now that's true because the bases are the same, and that's a key thing right here. As long as the bases, they're both a base of 5, you can just grab your exponents and say that the x is going to equal that exponent. So 3, straight up and easy. Again, main takeaway there is that the bases have to be the same. Write that in nice and bold. The bases must be the same. Big idea, because if they're different bases, which we will start to see in the next lessons, that's going to change a little bit of how we deal with these. All right, let's take it from example A. So if we have this exponential equation, 4 to the 5th power equals 4 to the 3n minus 1, it's really nice and easy. You're actually going to go back to just some basic Algebra 1 level type of solving. The bases are the same. And as long as they're the same, you can sort of cross them out. Like ignore them. They're not technically like crossed out or canceled in any way, but you don't need them to solve the problem. If they are the same, you can just straight up focus on the exponents, this and that. Well, they're on different sides of the equal sign, so you do have to make an equation. It's the 5 has to equal the other one, the 3n minus 1. Because 4 to the 5th has to equal 4 to the 3n minus 1. But the 4's are the same anyway, so we don't need them. Now at this point, we're just solving for the variable n. And this goes back to just some Algebra 1 solving. You want to isolate the variable. So we could add the 1 to start with. That'll give us 6 equals 3n. And still trying to get the n by itself. Currently, that's 3 times n. So we should divide by 3 to get rid of it. And then that will solve the variable n equal to 6 divided by 3 is 2. And there we go. That's solved. Now if we were to take this, n equals 2, and plug it in here, well, think about what you'd get. 3 times 2 is 6. Take away 1 is 5. So you'd get 4 to the 5th equals 4 to the 5th. Exact same thing. So it's equal. All right. Easy peasy. Let's try example B. Setup is similar, slight differences to it. Notice this time I have 2 to the 3rd, also raised up to the 4th power. So we have a power raised up to a power equal to 2 raised up to the negative x plus 1. Similar kind of thinking, the bases are the same. I'm just going to cross them out. We don't need them as long as the bases are the same. We're just going to focus in on the powers. Now be careful with the left-hand side because that doesn't become 34. It's 3 times 4. So you're going to need to make sure to distribute or multiply whenever you see something like that. So that's 3 times 4. 3 times 4. You can keep the parentheses if you want, just as long as you know to multiply, equals the other power, which is a negative x plus 1. And then you just do some simplifying. So 3 times 4 is 12. Equals negative x plus 1. Kind of going back to these Algebra 1 skills here, trying to get x by itself. It's a plus 1, so we could subtract the 1. And we get 11 equals negative x. Remember that a negative x is like a 1x, so that's like negative 1 times x, similar to the previous problem where we had to divide the coefficient. We're going to do the similar thing, it's just a negative 1 here. So now we are going to divide by negative 1. That way the negatives cancel and the 1, and then we just get a positive x equals 1 divided by, or negative 1 going into 11 is negative 11. 11 divided by negative 1, done. And you could do the similar kind of thing that I mentioned on the previous problem. You could take negative 11 and substitute it in. So it would be a negative of a negative 11, which would become positive 11 plus 1, so 2 to the 12th. and this is 2 to the 3 times 4 is also 12. You could check it out and verify they are going to be equal. A nice true equation. All right, one more. Let's check it out. So example C, again, some similarities. As long as you notice you have a base of 10 raised up to a power, base of 10 raised up to some more powers. I'm just going to cross out the bases just to not get distracted by them. They're the same. I don't need them. We're just focusing in on this power being equal to that power. So I have the x minus, I have a highlighter, sorry, x minus 1 equal to, now on this side it's 2, and then I'm going to put the whole expression 4 minus x in parentheses just to remember to distribute. It's okay to put the 2 in parentheses, but it looks more like how we've seen it in the past when you put the expression that is multiple parts in parentheses like this. All right, either way, you're going to have to distribute it out. Doesn't matter if you put parentheses around the 2 or not, it's going to work the same way. So there's going to be distributing here. The other side, x minus 1, that won't change. But then you have 2 times 4, 8, and 2 times negative 1x, which is negative 2x. And from here, a little bit more solving. Now this is a situation where we have variables on both sides. So ultimately we want our variables collected to one side and the integers collected to the other. So I'm going to get my variables to the right, or to the left rather, just because that tends to be where most of us like the variables. I also like the adding the 2x to get rid of it. We'll make it a positive on the left, just like a nice little personal preference. But now I have the 1x plus the 2x, that's 3x. Minus 1 stays the same, equals positive 8. Trying to isolate x, so if I add the 1, starting to get the x term by itself. So 3x, negative 1 plus 1 is gone, 8 plus 1 is 9. Final step to isolate is to divide the coefficient away, and so x equals 9 divided by 3 is 3. And voila, we now have solved that exponential equation. You can verify this one just like you can with anything else. Plug 3 in for this x and for this x, calculate it out, it'll be the exact same, and life is good. Right, and so that is solving exponential equations where the bases are the same. If you practice the problems on the posted assignment, you'll be able to check your answers, make sure you got the skills down for it. If you're having trouble, make sure to join for some online tutoring. Good luck, you've got this.